All right, I'm here to work through a couple more examples with the Central Limit Theorem. And we've transitioned here, we have proportions. So suppose that the true proportion of voters in a county who support a restaurant tax is 0.54. Consider the sampling distribution for the proportion of supporters with a sample size of n equals 126. What is the mean of the distribution and what is the standard error of the distribution? So go over here. Now, one of the things that's a little bit confusing about this is we have a proportion given to us, 0.54, and we have a sample size given to us of 126. Now, we can find Q by taking 1 minus P, and this isn't necessarily new to us, but PQ, that's success and failure, that kind of thing. Now, the mean of this distribution is the mean we're given here. 0.54. Now, my high quality miss is actually saying that the mean is this times this, but that was like an earlier thing. And then our standard error of a proportion here, it's the square root of P times Q divided by N. That was a formula we showed earlier. So P times Q divided by N. And just showing a little bit of work here, and I kind of forgot to show where I got this here. Anyway, and this relates to our normal distribution because these proportions are normally distributed, and this middle number here is the 0.54. So our mean winds up in the middle, and then we have a standard error of 0.44. So as we're moving along here, it'd be like 0.5 is like right here, 0.46, 0.42, and then we can go up this side here. Just adding a standard deviation, adding a standard error as we go. So for this one, we don't have any more to do here except for to write these 0.0444. But this is kind of building on some questions that we can answer here. Based on historical data, your manager believes that 29% of the company's orders come from first-time customers. A random sample of 82 orders will be used to estimate the proportion of first-time customers. What is the probability that the sample proportion is less than 0.27? So, getting our important information. Don't like it when I have my writing utensil here. So this proportion, this is P. This is what we get from what we know, 0.29. So based on the historical data, your manager believes that 29% of the company's orders come from first-time customers. That's this year. A random sample of 82 orders, so now we have a sample of 82 orders, will be used to estimate the proportion of first-time customers. What is the probability that the sample proportion is less than 0.27? So now we're talking about here kind of a p-hat, which might be a new character, but this is a value that comes from a sample. Now, from our data that we know, we can find Q by doing 1 minus P. And then we can find a standard error of our proportion. And again, it's the square root of P times Q divided by N. Now, we've got a 0.29 right here, and this can be a little bit tricky because we're kind of adding proportions along the x-axis and in here. Anyway, so we have a 0.27 and our standard error is 0.0051. So I'm going to just put 0.027 over here, or 0.27, I think I keep saying it wrong. We're looking for the probability in here. So we're using the probability here that our p-hat, or our sample here, is less than 0.27. We're using a normal distribution. So proportions are normal. We have the interested value. We've got the mean. We've got the standard deviation. And then we want the area to the left, so this is going to be a true situation. Just putting this here, and I'm going to drag this over a little bit just to make sure my probability. So 0.3449 is going to be our answer here. So we're using proportions, setting up a new distribution. It's normal. We have a similar question here. 32%, that's going to be our new P, and then we're looking for a between. So this is similar to what we were doing in the previous one. I want to keep going here just in case. Let's see. So, want to do one of these. According to a recent report, 47% of the population has a particular medical condition. In a random sample of n equals 290 from this population, what is the probability that at least 52.9% of the sample will have the medical condition? So, I guess we're looking for the right-hand side here for this. So, getting the important information we have here, we've got P 0.47, N 290, just interpreting from our problem. What's the probability that at least 52.9%? So this 52.9% right here is the same as this one here. And so we're getting kind of a new cutoff here. Or maybe it's a P hat, excuse me. Maybe it's an OP. So need to find a Q. That's going to be equal to 1 minus P. Again, you might be able to think through this and not use Excel. That's fine. The standard error is going to be equal to the square root of P times Q over N. And we got a distribution, so here we go. 0.47 is here. And with the standard deviations, it could be a little tricky to draw them, so I'm going to just put, say 0.529 is over here. And we're looking for this right here. So it's a right-hand side situation because it's greater than or equal to. And so when I'm looking for that right-hand side, I got to do 1 minus the area to the left. So 1 minus the normal distribution, put in my guy of interest, 0.529, my mean, and my standard error, the mean, and the true. And we get a value like this. So 0.0221, possibly, let me see here. Yeah, it's a 5.2. Sometimes you'll pull that out and it'll be a 4.9 and it would round down. Anyway, so. All right. There's a couple of examples with proportions. Just want to make sure you have a few of those. So we did the central limit theorem working with means and with proportions. And this should wrap up module 4 for us, and now we'll start preparing for the exam. So let me know if you have any questions. Thanks for watching, and good luck.